Example 2. Salaries of 47 college graduates who took a statistics course in college have a sample mean of $61,000. Assuming a standard deviation, sigma, of 13,424, construct and interpret a 95% confidence interval of the population mean salary for all graduates. Round to the nearest hundredth. So you want to get started by knowing what the formula for a confidence interval is. And when handling the 95% confidence interval, you have to note that the z-score is a negative 1.96 and a positive 1.96. Everything else about the confidence interval remains the same. You're going to take note of what I have highlighted in red here. We note that the size of the sample is 47. We note that X bar is 61,000, and we note that sigma is 13,424. So those three things basically get plugged into this formula. 61,000 minus 1.96 times 13,424 divided by the square root of 47. This will give us the lower limit of the confidence interval. 61,000 plus 1.96 times times 13,424 divided by the square root of 47 will give us the upper limit of our confidence interval, which gives us 57,162.14 to 64,837.86. So I'll show you on the calculator again how it's done. Okay, you put in your sample mean, you subtract 1.96, which is the z-score associated with a 95% confidence interval, multiplied by 13,424 divided by the square root of 47, enter. 57,162, and the reason why I said 0.14 is because it's money, and money is usually rounded to 2 decimal places. Now, to get to the other one, 64,837, it's really easy on the calculator. All you're going to do is second enter to repeat the previous entry and scroll over and change the minus to a plus. Okay, so change that minus in front of the 1.96 to a plus, and you've got 64,837.86. Okay, so when asked to interpret what this confidence interval means, we say we are 95% confident that the true population mean salary of college graduates who take a statistics course in college is from, and then we put our lower limit, 57,162.14, and our upper limit, 64,837.86. Now, this interpretation is going to basically be applied every single time. We always start by stating how confident we are, the degree of confidence in terms of percentages. It's either going to be 90, 95, or 99. And then we state that what we're confident about. In this case, we're confident that the true population mean and the variable in question is salary of college graduates. So we are estimating the population mean salary of college graduates by using a sample mean. And of mean salary of college graduates who take a statistics course in college, and then we put our limits. The margin of error is going to be found by taking the high limit, the upper limit, subtracting the lower limit, and dividing by 2. So if we do that, 64,837.86 minus 57,162.14. If you do it on the calculator, be sure you wrap the numerator in parentheses. And then after the numerator is wrapped in parentheses, so the subtraction is done first, you divide by 2 and you get 3,837.86. So this confidence interval could have been stated to be 61,000 plus or minus 3,837.86. That same plus or minus margin of error would give us the limit from 57,162.14 to 64,837.86. Okay, we're going to take this question and we're simply going to change one piece of it. We're going to find a 99% confidence interval instead of the 95% confidence interval. Everything else about the problem is identical. So we change our formula to have a negative 2.58 and a positive 2.58 for our z-scores. Now increasing our z-scores is basically going to widen the range of values, which gives us greater confidence. So we put in the same values again. 61,000 minus 2.58 times 13,424 divided by the square root of 47. 61,000 plus 2.58 times 13,424 divided by the square root of 47. Again, it's pretty easy on your calculator to just repeat the previous entry and change a couple of values. And you should get 55,948.12 to 66,051.88. The construction of the interpretation is the same. We are 99% confident. Okay, so we're just going to change our confidence the percentage for our confidence level. We are 99% confident that the true population mean salary of college graduates who take a statistics course in college is from 55,948.12 to 66,051.88. Okay, so by increasing your confidence level, you've also increased the range. The margin of error in this case, you're going to take high limit, the upper limits, minus the lower limit. Make sure you wrap it in parentheses, then divide by 2, and you get 5,051.88. Okay, so we could also state the confidence interval as 61,000 x bar plus or minus 5,051.88. That same plus or minus margin of error is going to give us the same range as we have here, 55,000 to 66,000. Okay, the relationship between the confidence level and the range of the confidence interval. A greater confidence level, for example 99% instead of 95%, means that there is a greater probability that the interval contains the true population mean. When you increase the certainty, you increase the chance that the interval contains the true population mean. For our 95% confidence interval, we had the lower limit to upper limit was 57,162.14 to 64,837.86. The margin of error was 3,837.86. And for the 99% confidence interval, we found it to be 55,948.12 to 66,051.88 with a margin of error of 5,051.88. Notice the range of values, 57,162 to 64,837 and 55,948 to 66,51. The range increases when we increase our confidence, and the margin of error also increases. So the result of increasing the confidence level is an increase in the margin of error, and a widening, the width increases of the confidence interval, because the margin of error and the width of the confidence interval go hand in hand.